right, hey guys, let's do AP Micro 2024 FRQ free response question. This is set 2, and this is number 2. And we can look at this and just know it's a labor question, or what some people would call a factor market question. Easy enough. These tend to be, it's one that we would call tables for labor. There's probably about 7 or 8 of these. Obviously, we have to know how to fill these things out. So number of workers, they tend to always give us number of workers. Here they called it total quantity. They could have called it total output. You and I should know it as total product. Anytime somebody gives us total product, you can be pretty sure you got to find marginal product. We're going to take that marginal product. We're going to multiply it by the price of the good. This is going to give us our marginal revenue product, which is also our demand for labor curve. We're going to compare that to our marginal revenue cost, which can also be called a marginal factor cost, which is the supply of labor curve, which technically is the wage. So this is all important, and this formula is stupidly important for a whole bunch of multiple choice questions. The tighter you have that in your brain, you can answer a whole bunch of multiple choice just by having that tightly in your head. So let's read down here, because they always tend to give us the price of the good and the wage rate. So let's just plug those in. 18, 18, 18, 18, 18, 18. And the price of the good all the way down. Got it? Then we're going to do our marginal product, which we know is just a change in total product over the change in quantity. The change in quantity is always 1, 1, 1, 1. So we're really just interested in that change in total product. Looks like we go 5, and then 7, and then 6, 5, 4, 3, 2, 1, and looks like a negative 1. We don't need to worry about the top line there. No workers, nothing's produced. There you go. So this looks like 50, 70, 60, 50 again, 40, 30, 20, 10, and a negative 10. Now, anytime I'm filling out these, the first thing I'm looking for is where profit max is. Profit max, as we should know, is always for labor where your MRP equals your MRC. If we had to draw a graph, and we should know how to draw that graph right off the top of our heads, we're going to do our market, we're going to do our firm, and we recognize that it's wage. We're talking labor, so it's wage on the vertical, quantity of labor on the horizontal. We're going to show that supply of labor curve. Here's our demand for labor. Notice I labeled them SL and DL. I don't want to get confused with perfect comp. This is labor, so I'm still going to draw it. You can see how they look very, very similar. This is your MRC, this is your MFC, this is your supply of labor, this is your wage. All of that is right there, $18, easy enough. Our demand for labor is downward sloping. This is our MRP, and where they come together, that is our profit max, where MRP equals MRC. That's our profit max quantity of labor right there. So they didn't ask us to draw the graph, but you should know how to draw that, and it should be tight in your head to know how to do it. Obviously, filling out the tables is stupid important. Make sure you know how to do them. Yeah, cool. All right, low and fee lines. Fixed cost is 90. Calculate the average fixed cost. We should know how to go from fixed cost to average fixed cost. Fixed cost divided by quantity gives us average fixed cost, right? So if our fixed cost is 90, they told us we were hiring 6 workers. Calculate the average fixed cost. At 6 workers, quantity would be 30. So 90 over 30, easy enough. Our average fixed cost is $3. They do want us to show our work, so make sure you plug all that stuff in. Assuming labor is the only variable input, calculate the marginal cost if output increases. So marginal cost, we should know the formula is a change in total cost over a change in quantity. They gave us the change in quantity, right, of 3. Our change in total cost, tricky. Total cost is always variable cost plus fixed cost. So our fixed cost here they gave us is 90. Our variable cost would be the number like labor. Anytime we see this is like rent usually, and variable cost is usually labor, almost specifically labor. So at 5 units, if we were talking 5 units, our variable cost would be 5 times 18. Let's pull out the trusty calculator here. 5 times 18, which would give us 90. So our total cost would be 180 for 5 workers. Easy enough, right? We're looking for a change in total cost. So we're looking for going from 5 to 6 workers. Our fixed cost still is 90. Our variable cost, though, would increase to, let's just do a plus 18 here. We're adding one more worker who's $18. Oh, that doesn't seem right. 6 times 18, 108. That's what I was looking for. There you go. 108 plus 90 would give us plus 90, 198. So remember now, it's the change in total cost. So it isn't the total cost, easy to get confused, it's the change. We went from 180 to 198. That is $18 is a change in total cost. The quantity was 3. 3 over 18 or 18 over 3 has got to be $6, I think. Do I need to plug that in? Let's do it. Divided by 3 just to make sure we're golden. All right. Easy enough. So, and they do want us to show your work. All of that would have got you the points, just like all that would have got you the points. There you go. Average fixed cost, average, marginal cost. That's what we're looking for. With the hiring of which worker do diminishing marginal returns begin? Explain using numbers. So anytime I'm looking or talking about diminishing marginal returns, I should have a graph in my head. I should have a marginal product curve that looks like this. And I recognize that, and just to complement it, marginal product and marginal cost are always mirror images of each other. So if I know marginal product, here's where marginal product maximizes. Therefore, marginal cost would minimize right there. Any output past that point right there, any of this output on this side, is diminishing marginal returns. The way I like to say it in my head is anytime marginal product is going down, or marginal cost is going up, I know I have diminishing marginal returns. Helps you with a whole bunch of multiple choice questions. So when we look back at our table, we notice that marginal product starts at 5, it goes to 7, and then it starts going down to 6. So our diminishing marginal returns always start where marginal cost goes down. We don't have marginal product. We don't have marginal cost. We only have marginal product here. So we recognize that when marginal product starts going down, that is when diminishing marginal returns kicks in. So I would say, and they want us to explain using numbers, and I would say with the second worker, marginal product reaches a maximum, and with the third worker, marginal product decreases. Therefore, diminishing marginal returns starts with the third worker. Little bit wordy here, but the point is we want to tell them where it's reaching a maximum or that it's going up on the second worker and then it's falling with the third. That's the first place that it falls. Therefore, that's where diminishing marginal return starts. Again, I should always have this graph in my head. It helps with a whole bunch of questions. Determine the profit maximizing number of workers and explain using marginal analysis. If we look back up here, we recognize we know where marginal revenue product equals marginal revenue cost, or where they are as close together. That would be the perfect number of workers, or the profit maximizing number of workers for us. Recognize as long as MRP is greater than MRC, you keep hiring. This guy brings $50 into my company. I only pay him $18. I'm definitely going to hire him. This guy brings $70 into my company. I only pay him $18. I'm hiring that guy. This pays $60. You see what's going on here, right? So as long as the MRP is greater than the MRC, we keep hiring. Soon as the MRP is less than the MRC, we would not hire that worker at all. So neither one of these two are going to get hired. The last worker we would hire is number 7. Notice they're not the same. And that's okay. We can't hire a partial worker. We can either hire 7 or 8, and we are as close as possible to being at profit max without having our MRC or the wage greater than what they bring into the company. So if we have to stop right here, that's cool. That's the best we can do. We'll stop right there. And that would be the number of workers. So let's see, explain using marginal analysis. So I do this the same way like a child. I'm going to say I would hire up to 7 workers. Hire up to 7 workers as the marginal revenue product is greater than the marginal revenue cost, not the 8th worker as marginal revenue product is less than marginal revenue cost. So this is the way I fill in with this marginal analysis. I just want to tell them I'm hiring up to the 7th worker because MRP is greater than MRC, not the 8th worker as MRP is less than MRC. I think that'll get us all the points. All right, let's look at number E. In the long run, a rival company, Gatto Food, increases its production from 40 to 50 units and its total cost increases from 600 to 900. Now, recognize that we're not so worried about total cost here. Output went from 40 to 50. Are they experiencing economies of scale, diseconomies of scale, and constant returns? What we know, if we draw that long run average total cost, we can split this up into 3 sections. We know this left side where average total costs go down is your economies of scale section. This, let's just pretend it's flat. We're going to call that constant returns or constant cost section. This is economies of scale right there. Anytime costs are going up, specifically that long run average total costs are going up, we know we're in the diseconomies of scale. So when we look up here, we recognize that at 40 units, the cost, our total cost was 600. So if we take that total cost and divide it by quantity, that's going to give us an average total cost. And our average total cost, again, trusty calculator, 600 divided by 40 is 15. So our average total cost is 15. And then when we move to 50 units, our total cost went up to 900 divided by 50. The quantity, 900 divided by 50. Should be able to do that in my head, but let's trust the calculator. $18. Look what happened to our long run average total cost, right? It went from 15 to 18. Your long run average total costs are going up. So we're going to say that we're in the diseconomies of scale section. And we did that explaining how those long run average total cost numbers went from 15 to 18. I hope that makes sense and it's clear to you. Lots of moving pieces on this one. Probably the hardest one I saw from last year. All right, keep working hard, guys. You're doing great. Be safe.